big enough?
A little bigger. It didn't really hurt. It just scared me.
Bigger?
You can still feel it. I'm really nervous. That's good. That's good.
Okay. So we're going to talk about R. Start, and then we're going to just, this has like a, it gives us some examples we can kind of guess. Oh, this is zoomed in, so I don't know if I can write on here.
Can you recalibrate while it's zoomed in to do it?
No, that's just too much. Okay. So if the dots were in a perfect line going up, your R would equal 1. That would mean it's like a 1-to-1 correlation. 100% of the data is exactly on that line. If you had like a random scatter where there's no pattern at all, that would be R equals 0. R is just like the relationship. If you had a straight perfect line going down, R would equal -1. And then you can get into kind of in between too. So if I look at, look at that, I got bigger. So if I look at these, take a second and see if you can match up these 4 numbers with these 4 graphs. So like I'm looking at, okay, these 2 on the left-hand side are both negative, right? They're both going down. But the one on top is a stronger relationship. Stronger is going to mean closer to 0 or closer to -1. Closer to -1. So that's going to be my -0.75. That's going to be my -0.66. Same thing on the right. This is, what is this garbage? Oh, there's 3 negatives, aren't there?
Yeah. Point.
So that's positive, that's easy. Okay, so then this one, I think, do you guys think this one down here is the weakest one?
Yeah.
I do also. So that's going to be the one that's closest to 0. We agree?
Yes.
4 correct. 4 happy faces. Try again. Stop giving 3 negatives and just give 2 and 2. How hard is that?
Well, I know the one.
Goodness gracious. I'm not asking for perfect. I'm asking for reasonable.
Wait, what happened if there's only 1 point?
The bottom ones are very close. And obviously the 2 is.
So this one's the negative one, right?
Yeah.
That's pretty easy. I think this is the weakest positive one. Do you agree?
Correct.
Yeah.
So that's going to be the 0.61. These are pretty close.
The bottom right and the left one is. The bottom right is stronger. Bottom right is stronger.
I think this is the stronger one and this is the weaker one. Let me just tell you this though. The AP test would never make it that close.
That's ridiculous.
There's no way that they're going to expect you to eyeball the difference in R between, like, they're that close to each other. They'll make that your choices for R spread apart, like, far enough that it'll be clear. I'm not even sure this is right.
I knew it.
It's mad at you.
I told you
I
guys.
know, look how angry it is.
Because the yellow is more prominent on the
dumb.
other one, which means there's more. Is it just because there's more dots around it?
Try that one.
Wait. Which there's what happens if there's only like 1 point on the graph?
Then it would just be 1. Well, actually, I don't know if it would be 1 or negative
What if
1.
they were just
You would
2?
need 2.
What if they were 2?
It would have to be 1 or negative 1 because every point would be on that line. You would just connect them.
Is the top right negative or the bottom left negative?
So we agree with these two, right?
The top right is not.
And then the question is, so one of these it's saying has a, if you were asked to describe these, there's 2 things you're asked to describe. One is you're going to say like strong or moderate or weak. Both of these are weak, right? And then the other thing it has to be described is positive or negative. So I'm having trouble. I think. You guys agree with that?
Yeah, I think so.
Yes.
No idea. So there's one of these on your con. Let's just take a second and let me pull up some problems from there.
These were a lot.
Oh, these are not too bad.
These were fun,
Yes.
so I don't even need to go through.
Correct.
Oh, okay. So that's what I mean. They're like farther apart, right? Like you can tell what the difference is. Okay. Let me go back to, let's say, one of these. Let's say, here. The only way you can really find the number is putting your calculator. We're not going to be doing that by hand. Alright, so this is, let's just look at this one. We're going to zoom in on this bottom right here. So our regression line, I'm sketching it. I know this is not like the ideal way to do it, but it probably goes something like that. Fair enough? Okay. So right now R is negative 0.78. I'm going to add a new point, and I'm going to give you options for what R would turn into. So I'm going to put a point right there. Is R now, so these are your two options. Don't say it out loud. But I want to know like which, this is supposed to be a negative, not like a triple equal sign. So what did that do to R? Don't say it out loud again. So think about it, did it make the relationship stronger or weaker? So go ahead, stronger or weaker? Weaker, because I put a point like really far away from the line, right? And does weaker make it closer to 1 and -1 or closer to 0? Closer to 0. So it would be this, I mean, I don't know if that's right or not, but it would be more toward negative 0.5. It would draw it closer to 0. Same idea, let's say I put a point, and you'd probably have to put a couple points to really impact things here. Well, let's just say I moved a point. Let's say I take this point here, and I move it. And I put it right on top of that line. So again, think about what R would do. Did the relationship get stronger or weaker? Stronger, because I took a point that was like kind of far away and put it right where it's supposed to be. So closer to 1 and -1 or closer to 0? Closer to 1 and -1, so this would be A, right? That make sense? Okay. Alright, let's get out that, let's look at that packet.
You didn't write that in marker, did you?
What's weird?
Like, when you erase it, like, you can still see, like, it looks like you erased, like, an actual marker.
Oh yeah, there's like a trail of it.
There's, like, a residue, and then it, like, slowly fades away.
Where'd my remote go? Okay, so in your packet, there's these 3 examples in the front. If you go to the back, there's like notes on each thing we have to know. So the first thing on there is notes on R. So R is correlation. You're gonna have one of the hard things about this chapter is you're gonna have R, which is correlation. You're gonna have R squared, which doesn't really have another word, it's just R squared. And you're going to have residuals. So there's 3 words that start with R. And I'm just kind of keeping track of which is which can be tricky. But regular R, if I just say what's R, that's correlation. So that's that, like a perfect one up would be R equals 1. Random, no pattern at all would be R equals 0. And perfectly down would be R equals -1, and then, anything in the middle. so if you're asked, a lot of times they'll ask you to estimate R, which we just talked about, and I think that you guys are okay with that. And then a lot of times they'll ask you to describe R. If you're describing R, you have to tell me two things about it. It tells you two things. It tells, well, you tell me. What does it tell you? What does R tell you? Strength. So one is strength. And your choices are basically like strong, moderate, or weak. And they're pretty generous with those. Like if they think it's weak and you put moderate, you're probably okay. If they think it's weak and you put strong, now you might be in trouble. But they're pretty generous about. Okay, so let's just practice. R equals 0.8. Strong, moderate, or weak? Strong. R equals negative 0.2. Strong, moderate, or weak? Weak. R equals 0.5. Strong, moderate, or weak? Moderate. I mean, so that's how, that's how, it's not like a precise thing. It's just kind of estimating. And then what else does it tell you? It tells you direction, too. Good. So it also tells you if we have a positive or a negative relationship. And then if you are asked to describe it, or describe anything in this class, what else do you have to include? Context. Form's coming later. So if I ask you to describe R, I would say something like there is a blank relationship, and I would put like strength here and direction here between blank, and that's the context of the question. I don't know if that makes sense, all those blanks, but I think you'll get the idea when we do a couple. So for example, there is a strong negative relationship between, let's say strong positive relationship between height and shoe size. Like that's what we did in class the other day. Okay, turn the page. Is everybody still writing? Okay, so go to the front one, like number 1. And I didn't give you labels for these yesterday, but let's label it so we can start talking about it like in context. So let's say that L1 is your midterm score, not yours. Hopefully nobody gets like 10s and 20s in the midterm. Someone's midterm score. And then L2 is the final grade, the score on the final. So like, could I use the midterm to predict someone's final grade? Or their grade on the final? So R, in this problem, you guys all calculated it. Hopefully you guys have this 0.993. Everybody get that yesterday, the 0.993 for R? So if I ask you to describe this, you would say there is what's the strength? Strong, positive relationship. How do I know it's positive? 2 ways. One is it's positive, like that's the obvious way. How else? The line's going up. So if the line's going up, it's going to be positive. Also, if it's a positive number, it's going to be positive. I mean, that's obvious, but because the line's going up. There's a strong positive relationship between midterm and final. Did you guys write the equation yet? You guys did it yesterday? So, did you just use like y and x? So then label it now. So say like y equals, so yesterday you probably wrote this, y equals, I don't even know what it is, 0.946x plus 2.78. Did you put the hat on? Alright. And then off to the side, now you can say y equals final, x equals midterm. And again, what is that? What am I doing? What am I including? Context. Always context. They always want to know that you're like thinking about what's going on in that problem, not just doing like math alone, basically. They want to know you're thinking about the situation. Okay. Did you guys get to number 2? I can't remember what class did what. Did you guys do number 2 yesterday? Yes. You did already? Alright, I'm going to skip the graph, but I'm going to put someone just tell me, what's the regression line equation? Minus what? Do I have agreement there? Okay. What am I forgetting though? A hat. And now let's add to it. And let's say y equals cost of pizza. And x equals number of toppings. No, 7 toppings. $50 though. Yeah. So x is always on top. Y is always on the bottom. Well, and think about it too. X is the one that, like, you start with X, and that's used to predict Y. So if I call up a pizza place, I would say I want a pizza with 2 toppings, and they would tell me the price. I wouldn't say I want to spend $50, and they tell me how many toppings I get. You know what I mean? Like, one of them comes before the other. What was R in this one? 0.97? Okay, interpret it. Go ahead and write down the interpretation. Interpretation. Seemed like too many syllables for a second. Interpretate it. I like these new seats. You're really far away from me, Dan. I moved all the rows over, so now David's like twice as far away from me, and that makes me happier. He had like knee surgery, yeah. Is he? Really? Did the surgery go okay? Like, did you say, okay. It just sucks, yeah. Really? Alright, so I would say, you can phrase it differently too. I'll phrase this one a little different. The relationship, you don't have to phrase it this way, but I'm just giving you another option, between toppings and cost is strong and positive. So just a different, like, I'm just flipping it around, you know. I'm not like an expert phraser. As long as you're saying strong, positive, and then you have the toppings and the cost in there somewhere, you're probably good. All right. Question on that one? And you didn't do number 3 yet, right? Let's just, don't do it yet, but let's write down the context. So the top row is going to be Milan temperatures, and the bottom row is going to be Toronto temperatures. We'll get, don't do it yet. Because what I want to do is get through all the notes, leave this one blank, and then be like, okay, now do all that stuff that we talked about. Alright, the next thing I want to get to is slope. I want to do slope next. So we're going down to the bottom. So go back to like the notes on part. I know I'm flipping you, packing around a bunch. Why did you just say it's only Tuesday? This class is killing you?
Oh, that reminds me.
Thank God. We don't have to talk about it. It's on, everything will be on Schoology. We just talked about it. Okay. For slope, what is slope? So I'm going to, let's rise over run. Why did I spell rise wrong? This is really that complicated? I know how to spell rise. Let's get that. It's R-I-S-E. Let's get that squared away. Why did I spell it wrong? Because Y's go on top. I'm trying to teach people things. I thought so, but everyone's making fun of me like I'm some idiot and can't spell a 4-letter word. You just teach math. You don't know how to spell it. So it's the change in Y over the change in X. And that's what you need to describe in, like, what they'll say is find the slope and interpret it. You need to basically describe this in words. And usually it's going to be some change in Y over 1. Like, that's typically how the slope goes. But there is a little twist in the phrasing. So the slope for the shoe size, and let's just kind of, don't even write this down. I think your guy's slope was like 0.4-ish. I don't know, ish is fine. So I could go, okay, that's 0.4 over 1. This would be an incorrect way to phrase this, and I want you to understand why. For every additional inch that a person's shoe size increases by 0.4. The idea is right, but there's one weird thing there. For every additional inch that a person is tall, that's awkward, but whatever, their shoe size gets bigger by 0.4. It's kind of close. But is that true that, like, so if I just grow 2 inches tomorrow, my shoe size will just right away just grow with me and it'll be 0.8 taller? Or is this, like, on average what we expect? This is what, on average, what we expect or what we predict. So the phrasing that you want to use here is you want to say for each additional, and then you put like the x value in context. We predict or we expect y context to increase or decrease, so we got a lot of things going on here, by whatever. There's a lot of things there. It's not as bad as it seems. We done writing? Can I turn back? Yeah.
Yeah. So like on the AP test, are we supposed to explain this way?
Yeah, and we're going to go through a couple of them. Yeah. Can I turn the page? All right, so go back to that first one. Did you say no?
Yeah, I did, but I couldn't figure it out.
Here. My bad.
No, look, it's up there.
Oh, I got it.
Stop looking at me. Okay, so go to the first one. The easiest way, so I think the best way to do this, and it takes like a little bit of extra writing, and some people just get lazy about it, and that's your own fault. If you screwed up and you're lazy, that's on you. But I like to go, okay, I'm going to put change in y over change in x. Because that just, do you guys know what the delta means? Delta means change. So this is like the change in the y value over the change in the x value. Okay. So that's 0.946 over 1. And then I'm going to take it a step further. And what is the y value in this problem? The final grade, right? That's what we said? And what was the x value? This is what you have to describe. When your midterm grade goes up by 1, so tell me if I'm saying this right or wrong. When your midterm grade goes up by 1, your final grade will go up by 0.946. Can I say will? Like I have the kind of general phrasing right, but I gotta say the predict part, right? When your midterm score goes up by 1, we would expect your final score to increase by 0.946. Fair enough? So write that. When midterm goes up by 1, we predict, we expect, whatever. We predict final to increase by 0.946. And you don't have to show this part, like this is kind of like I'm just wording it in math. I'm getting the math part down first and kind of organizing my y and x, and then writing the sentence. That really helps me. I think it helps a lot of people that actually use it. If you can get by without it, great. I'm not going to make you, but I think this step is pretty helpful. So go to the next one and so interpret the slope on the pizza one. R is not the slope. We didn't write that by slope. I didn't write it by slope, did you? Okay. The numbers are like really close. But that's what gets confusing. Like it's just terminology. So go to the pizza one and interpret the slope. What is the slope in the pizza one? The 8.14, right? So I'm going to go 8.4 over 1. Kind of remind myself that's y over x, and y is cost, and x is toppings. And then I'm just going to describe that. So for each additional topping, we expect cost to increase by 8.14. I mean, that's dollars is not going to hurt you, or whatever. That's cool. No, I mean, either way. Is that one okay? Good there? This is high level pizza here. Alright, go to notes on y-intercepts. Turn the page. Any point on the y-axis, the y-intercept, like if you were in advanced algebra or algebra 1 and I said find the y-intercepts, you would plug in 0 for x. So the y-intercept, the x value is always 0. And so all this is, if x context is 0, we expect y context to be whatever. Sometimes this doesn't make sense. You'll get so the shoe thing, it would be, if someone were 0 inches tall, we would expect them to wear a size -31 shoe. Doesn't make any sense, and sometimes AP tests will ask you, does this make sense in real life? And you'll be like, no, that's stupid. So that could happen where it just doesn't work, but because you'll never get a height of 0. But you gotta know how to do it anyways. So go back to the first one. What? How are you not done writing that yet? Good? Everybody else? Alright, so go to the first one here. Give the y-intercept and interpret it. So this would be, what's the x context in this one? So I'm right here. I know it's getting hard to tell. What's the x context in this problem? The midterm. So if the midterm equals 0, we expect, what's the y context? Final to be 2.78. So if you get a 0 on the midterm, my prediction is you will get a 2.78 on the final. So you improved from 0 to 2.78 just by doing probably nothing. Right. Do the next one. Do the
278% growth. So
It's actually infinite.
infinite growth.
Yeah. Do the one on the pizza. Interpret the y-intercept there. So this one does not make sense in real life. Yeah, I would just go start getting no topping pizzas everywhere I could. Here's a pizza and $12.57. I know a couple of the cons you were asking about yesterday. We just talked about. So, yeah. Well, and the interpret slope and y-intercept is.
And with the r squared, it's a little different.
We didn't do r squared yet. We did r. R squared I'll show you in a second. Yeah. Okay, so give the y-intercept and interpret it. So, a pizza with 0 toppings. We expect to cost negative $12.57. So they owe me money and a pizza. This is great.
Is cheese a topping?
It is?
That's just ridiculous.
I thought you always got the
Do you work at
bread, sauce, and cheese.
where? So if I just call up and say I want a pizza with no toppings, what would you give me? A cheese pizza? Right? So cheese isn't a topping.
It's a breadstick.
Right.
Yeah.
Cheese is like default.
Yeah,
Yeah.
cheese is. I think they would ask if you want cheese. Yeah. If you
Do
don't
you-
want a pizza, you need pizza with just sauce.
So you would just give me like a crust with sauce on it?
Well,
Okay,
Yeah.
Wait, that sounds so stupid, but I actually had to make a pizza the other day like that.
But did they say I want no cheese?
Yeah.
did it say I want
Pizza.
I want lactose.
I mean, a plain pizza is just cheese pizza.
Right. This is becoming. This is not really that important.
This is important.
No.
Eggs.
R squared is way more important.
If you don't want cheese on your pizza, then you don't need to like get out.
I can't eat dairy, so are you telling me I need to get out?
Yeah.
Do you want to fight?
Yeah, do or like make like.
I wouldn't order a pizza
Like,
though.
don't just order pizza with
Right.
sauce on it.
Okay, find R squared. So just keep in mind what's happening. We got R, which is correlation. We keep saying relationship, which starts with an R. We're going to learn about residuals, which starts with an R. R squared is a whole different thing. This is literally you take the R value and square it. I mean, that's what R squared is. Why would I square it? What will happen? What's true about every number after I square it? No, gets bigger is not true. What's 0.5 times 0.5? 0.25. That didn't get bigger. It always gets positive. So it's always positive. And I'm going to, it kind of irritates me they put this in this class, to be honest, because this is kind of an advanced thing, and they expect us to teach some of it, but not really enough of it to where you actually understand what it means. They almost just want us to teach, like, that you memorize the definition of it. So, if you are curious to look up, like, what's actually going on, you could Google it, we could talk about it, we can have a little R squared conversation if you want. But really what you have to do for the AP test is memorize the phrasing. And I hate doing this because I like explaining like why things work. But explaining why this works is like, it'd be like another 2 lectures. And it's just not worth the time. So R squared is the percent of variation in the data explained by our regression line. And you are just going to memorize that, but I'm not done. Because what am I missing in that definition? I'm missing context. So then you would say on blank and blank. And they almost all, I don't think I've ever seen them not use this phrasing. That's a 2-hour explanation. And I'm just, that's what I'm saying. Like, I'm not going to get into it. A general, I'll explain like a general idea in a second. Okay, say R is 1. And I said find the percent of the variation in the data. What am I asking you to find? I'm asking you to find R squared. Well, what's 1 squared? 1. That means that our regression line explains 100% of the data. Okay? That makes sense, right? When I lower those numbers, it starts to get a little goofier. Let's say R was 0.5. And then I say find the percent of the variation. Well, what's 0.5 squared? 0.25. So that means that 25% of the variation in the data is explained by our line. So the shoe size thing. Does anybody have R squared from the height and the shoe size on that chart? Do you guys know what it is? Remember we did the height and shoe size, the big giant graph, and you guys... 0.76 is R squared? Okay. What that means is that 76% of shoe size can be explained by height. But are there any other factors that could contribute to shoe size? Just like genetics, I guess. I guess that's probably the only one. So that's the other 24% that's missing there. So here, let's go back to, that's about it. Okay, let's say I'll give you this. Time you study versus your grade on the test. Okay? And I say R is 0.5. There is a correlation, you jackass. So you just don't know it because you never studied. So if I say R is 0.5, what's 0.5 squared? 0.25. So I would say 25% of your grade on the test could be explained by your studying. But what other influences are there on your grade on the test? How smart you are, like how much homework you did, how much you paid attention, if you came to class or not, if you brought your freaking calculator or not, if you were on time or not. You know, there's all these other things. So this is like the percent that is coming from the one variable that we're looking at. But there's like a whole nother, there's other things. But that's like a general overview of what we're getting at. Okay, so go to the front page. So this is really a pretty strong one. So this would be 98.6% of the variation in the data. And that phrasing is used every time. Percent of the variation in the data. So basically I'm saying this is pretty darn near 100, right? So it's almost saying like nothing matters except your midterm score. Which isn't really true, but in this example, there's only like 1.4% that doesn't have to do with the midterm. So 98.6% of the variation in the data can be explained by the regression line. And you can do this too. You can write LSRL. That's least squares regression line. So it's a little shorter. Same thing, LSRL. What am I missing though? Context. So on, midterm, and final. No, it wouldn't matter actually. As long as you're putting the context there, the orders, either way. Do the next one. Do the pizza one. Interpret R squared for the pizza.
Does that mean that percentage of data is at the line?
No. Because that's not true. It means that that variable explains 98.6% of the line. So there's like 1.4% in this case that is explained by something else. So yeah. And even that's like a yes. So R was 0.97 here, so what's R squared? Like 0.94 or something? 0.94 exactly? 943? Okay. So 94.3% of the variation in the data can be explained by, and I'm just going to write LSRL because that's shorter, on, and then context, toppings and money or toppings and cost. So that's a lot of stuff. That was a